Hello and welcome to regular expression engines, tools and environment. First simple question would be, what is a regular expression? And the answer is a regular expression, also called regex or regex P. Actually it is regular expression, also sometimes called a rational expression, is a sequence of characters that define a search pattern. Usually this pattern is then used by string searching algorithms for find and replace operations on strings. You can think of regular expressions as wildcards on steroids. Now regular expressions are used in C, C++, .NET, PHP, Python, JavaScript, Perl, Ruby, etc. Now more than 90% of the regular expression syntax is same for all these programming languages. However, there are subtle differences between these. All of these programming languages have regular expression processing engine, commonly called as regex engine, and these programming languages, they are called when regex is used with them, they are called different flavors of regex. Most of the syntax and rules and regulations are same and common. However, there are some differences also. This course covers regular expressions for all programming languages, and then you can move on to a specific language. As you would know, 95% or more of the syntax and rules and regulation, and then you can apply 2, 3 to 5% of that specific programming language rules and regulations. So if you are from any programming language or you don't know about any programming language, this course is going to help you understand and work with regular expressions. Now the work environment and tools for regular expression. In Google, if you write online regex tester or online regular expression tester, you will get these results. All of these are good regex engines. I mostly use regex101.com or regex Paul, yes, here, or regex Tom for .NET. Now I will like to show you one or two engines here. This is regex101.com. Now here you can select a flavor, like if you are working with PHP or PCRE or JavaScript or Python or Golang, etc. You may select your flavor, and as I have told you earlier, most of the things are just same, subtle differences. This engine is good for many reasons. It is very fast and accurate. Here you are going to write the test string. Here will be the text. So this is test string area, and this is regular expression area or window bar, where you are going to write your regular expression. Here this engine gives you explanation why there is a match, why there is no match, and here match information, the number of matches and their position, and the quick reference is also available, and here explanation, etc. So overall this is a very good regex engine, and we are going to work in it. This is regex PAL, and this is also available offline, so you can work with it without being connected to internet. This is the testing area. Here you are going to write the regex, and you will be shown result here, what is the match, so one match, etc. You may change the language or flavor from here, JavaScript, PCRE, and PCRE stands for Perl Compatible Regular Expression Engine. This is regexer.com, regexr.com. This is the area where you write the regular expression, and this is the text in which you want to search and match. This is also a good engine, and it is available online, of course. So these are a few online and offline regular expression engines. We are going to work in regex101.com, this wonderful regex engine, simple and efficient. Next lecture is start of regular expression basics, part 1. Thank you. Hello and welcome to regular expression basics, part 1. First topic is regular expression syntax or regex syntax. Now let's suppose we have to write a regular expression. First we put a forward slash like this. Then we write our regex and place a forward slash at the end. In simple words, we enclose our regular expression between two forward slashes. Now let's suppose you want to write the regex star. That means you want to match star in a string of text. You will write it as a forward slash. Then you will write the word star and another forward slash at the end. Another example will be if you would like to write or match the word tree, then forward slash tree and another forward slash. These forward slashes, one at the beginning and one at the end, differentiates a regex from the rest of the string or text. And this pattern or syntax is present in almost all of the flavors of regular expressions. Now let's apply it using regex engine here at regex101.com. This is our test string. Twinkle, twinkle, little star. This is our test string, and we write star here. Please note that we are not going to write the forward slashes here, as at regex101.com they have already placed forward slash at the beginning and at the end. Star is the word to match, and we can see this engine has matched the word star here. The word which is matched is highlighted in light blue color. So this is writing a very basic simple expression and matching it or searching it in the text string. Again, for second example, this is our test string. Tree provides us oxygen, and we want to search for the word tree. We write tree here, and it simply matches here. Now similarly, if there are numbers and we want to look for the number combination of 1, 2, 3, 4, and here it matched, and this is forward slash, and this is the another forward slash at the end. So the syntax of regular expression is you have to put the word, the search pattern in between two forward slashes. So very simple, isn't it? Similarly, the whole course is going to be simple like this. We will gradually move from very basic and simple things toward the complex things. Thank you. Hello and welcome to Regular Expression Basics Part 1. The topic of this lecture is literal characters. This is the most simplest match in regular expressions. By literal, we mean taking words in their usual or most basic sense. And characters, well, a single letter or a group of letters, like alphabets or group of alphabets known as words. Now these words could have some meaning, or it's not necessary that they have some meaning. Just a single letter or group of letters, or any combination of numbers like 1 2 3 4, like 9211. It is simply anything what it appears to be. Just like A means A, B means B, cat means cat, car means a car, and a combination of numbers 9211 means 9211. Simple. And if you want to search either A or B or a cat or car in our test string, it will be the simplest match. We will just write these in the regex box, and then we will search it in the test string. So the most basic or simplest search or pattern matching is literal character match, and no symbol, nothing complex involved, simply a character or a group of characters which we sought to match. Now moving towards our test area, regex101.com. Now here, this is our string, test string. This is a car, this is my car, I like my car, it has a beautiful look, and we want to match a character literal A, and you can see it has matched A, and at more than one place. In fact, it not only has matched A, but anywhere it could find A. So there are total of, you can see here, 7 matches. Match information given here, there are total 7 A's in our text. So any occurrence of A, either as a single letter or in between any word, it will match that. To avoid it from matching A in different words, there is a special syntax or pattern for that. For the time being, A will match any A in the text, and there are total 7 matches. This is the match information box, and which will show you how many matches. You can see the matches here, they are highlighted here. The regex engine starts matching from the extreme left and then moves on towards right. For example, the regular expression is A, and it will look for, is this A? No. Move on to next one. This is A. H. No. This is A. No. This is A. No. This is A. No. Space. Then again A. No. This is I. S space I. Oh, this is the first match. You can see here, match 1, group 0 A, position 8 to 9. Position means the position of characters including spaces. So it is at position from 8 to 9, starting from 8 and going up to 9. Of course, is a single character. Then again it will go for, okay, space, no match, C, no match, A. Okay, it is a match. So this is match 2. This is the second match. So A, this character literal A will match all A's in your test string. So simple. A matches A. Now let's suppose you want to match A as a single character. You don't want to match A in car or beautiful or has, etc. So then what would be the pattern? I am just writing it, we will discuss it later. Just we put boundaries here. Simplest method can be B and B. So now you can see here only 2 matches. this is a car and it has a beautiful look. But for the time being, we will discuss these boundaries later. We are discussing character literal. I just wanted to tell you that we can sort out and can match any specific letter or a set of characters. But in literal character, literal match, the word will match any occurrence in the text string, and it will search from, it moves from left to right. Similarly, a B means simple B, here B. So only one match. This is B in beautiful, and it is part of that word. As this is the simplest match, so we are not discussing either it is a word or full word, or it has boundaries, it is at the start, end, etc. Similarly, if you want to match car, and it will match all cars here, and you can see this is match 1, this is match 2, and this is match 3, and it is moving from left towards right. It will match all cars here. Actually, when we try to match a group of words, it works like this. It takes out the first letter from here, C, and it looks for C. This is C, no, this is T, H, I, S, so no C, a space, no C, I, no C, S, no C. So it keeps on searching and looking. Space, no, A, no, space, no, C, oh yes, this is a match. But hold on, now next is A. So just after C, is there an A? Yes, okay, that's fine. Then it looks for R. Is there R? Yes, there is R. Okay, this is the match number 1. So first it looks for C. If it finds, then it starts looking for A, and if it finds A, then it starts looking for R, and if it finds the whole combination, it highlights it and says it is match number 1. So if we write here can, car, call, now by searching all here, when it moved up to here C, okay, it is C. Yes, this could be the case. Then A, yes, going in the right direction. R, no R. Okay, no match. Move forward. Okay, C, yes, C, A, yes, A, and R, okay, it is a match. Move forward, space, okay. So it starts searching for C, then after C, successive A, so it goes for C, yes, this is C, then it goes for A, okay, A, it could be a match. R, no R, okay, no match. And it moves L, okay, no match, and then the end of string. Okay, this is all. So there are 4 matches, match information 1, 2, 3, 4. So regex101.com is a very wonderful and amazing regex engine. It gives you plenty of information about matches and other explanations. For example, here you can see car / car matches the characters car literally, and if we write here as A matches the character A literally, so this is a literal character match. Similarly, if you want to match numerical literal character 9211, simply it matches any occurrence of 9211 and 1011 street, so it only one match. If you write 9217, it will not match it, because it is looking for a combination of a group of characters in this pattern. 9, after 9 2, after 2 1, and after 1 1. So it will go for 9217. No match. And 9211, yes, there is a match. And if it is 9211178, there will be also a match. If we want to avoid any matches like this, then we will have to set boundaries, like 9211 is a single word. In this lecture, you have learned how to conduct a literal character match in Regex, and simply matching words or a group of letters, characters, numbers in your test string. So this is also very simple. Thank you. Hello and welcome to Regular Expression Basics Part 1. In this lecture, you are going to learn about regular expression modes or flags. Modes change the behavior of search pattern such that applying different mode will yield different results. So it is very much necessary to know about modes used in regular expression. There are a number of modes used in Regex, and some of them are quite specific to some flavors. However, I am going to discuss here 5 basic types of modes which are used in Regex more often. But before discussing the 5 different types of modes, first we discuss the syntax of a mode, how it is written. So the syntax is, we write the mode after the closing forward slash or the second forward slash. So first forward slash, the regex, second forward slash, and after the second forward slash we write the mode. This is the common syntax for all modes. Now we are going to discuss the 5 basic cases of modes or flags. Sometimes they are referred as flags instead of modes. The first one is global mode, used very widely. Its syntax is /regex/g, lowercase letter g, and g stands for global. Now what does it mean? A global mode or a global flag means it will search for all the instances on all the lines. In simple words, it will match all occurrences, or it will search for a pattern throughout the string. Case insensitive mode, it will match without considering the case of uppercase or lowercase letters. It will just look for a word and it will show the match. The next two are single line and multi-line modes. For case insensitive, we use lowercase I. For single line, we use lowercase s, and for multi-line, we use lowercase m as the mode letter after the standard regex syntax. Now, single line mode, it just treats the whole string as a single line. Even if it is composed of multiple lines, it will consider the whole string, the test string, as one single line. And multi-line mode, M will treat your string consisting of multiple lines. So S mode, single line mode, will treat the whole test string as one line, and M will treat your whole string consisting of multiple lines. Now, what will be the impact of this? We are going to discuss it later because we have not studied metacharacters. So we are, for a time being, you just get this idea. Single line means treating your test string as a single line, and multi-line means your string is treated consisting of multiple lines. And no mode, or the standard mode, or without any flags. So / regex / this will match only the first occurrence of your regex, of your search pattern, and will just return the first match, even if that word or that literal character or that number exists 50 times or hundreds of times. It will just match the first occurrence and will return it. That's why we use global mode more often. Now we are going to see the global mode, standard or no mode, and case insensitive in our regex tester. In regex101.com, by default, the global mode or G mode is on. Hence, if we write regex here car, it will search all the instances of car, and car, because global mode means it will search for all the instances on all the lines. It will match all occurrences, or it will search for a pattern throughout the string, throughout your test string. So it is very obvious and clear here that car and the whole test string is searched here, and it has found 4 matches for car. Now if we remove this G, and these are the regex flags or modes, and if we remove global, then no flag and no mode, that becomes the standard. And standard means it will match first occurrence. Here you can see it will match the first occurrence of car, even though there is car here, this is car, but it will match only the first occurrence. So this is the difference between global mode and standard mode. Global mode searches for all the occurrences, and standard mode searches for the first occurrence, starting from left to right. One more example to see the difference between global mode and standard mode. Let's suppose this is standard mode, and standard mode will search for the first occurrence of letter A, and you can see this is the first occurrence of A, and it will stop its search there and match 1, full match A. Actually, in case of a standard match, only there will be one result at maximum at the and that will be the first match. It is also possible that there is no match at all. For example, if I write Z here, your regular expression does not match the subject string. Z matches a character Z literally, case sensitive, and it is not found here. So if I write A and I apply global mode, then it will match all the occurrences of A as a letter or found in between words. So there are total of 12 matches here in this case. I hope that the difference between global and standard modes or flags is clear. So global mode and standard or no mode are discussed. Now we are going to discuss one more mode, and that is case insensitive. Single line and multi-line involve some complex symbols, and we will discuss them later. So case insensitive mode, by default the search is case sensitive. For example, if I write car here, it will match this car, this car, this car, and this car, because this car written is lowercase c, lowercase a, lowercase r. This car, this is written uppercase C, lowercase a, and lowercase r, so it is not a match. Similarly, if I write CAR, again it is not a match, because by default regex search or matching is case sensitive. It will only look for this specific case. Now if I apply case insensitive flag or mode, this is I, and it will result in matching all the occurrences of car, either it is a lowercase or capital or uppercase, and A and R lowercase, or all are in uppercase. So the word is itself is explaining and telling that case insensitive means it will search for all the occurrences without considering the case, and if we remove that, then it will become case sensitive, and it will match only those which are exactly the same case. For example, if I change it to capital C, okay, capital C, now it will match only this car, because this is structure is capital C, lowercase a, lowercase r, uppercase C, lowercase a, lowercase r, and it is not matching the other cars, even this car, because this is capital, capital, and capital. It will exactly match the case of every letter. Now in case of C, capital A, capital R, it will match this car, because these all are written in capital. If it is like lowercase c, lowercase a, and capital case R, now there is no match. Your regular expression does not match the subject string, because in our test string there is no car written in this specific case. If I write it here, it will be a match, lowercase a, lowercase c, lowercase a, and capital R, so it is a match. So this is by applying case insensitive, it will match all the occurrences irrespective of the case, and like this one. And if I remove this flag, and it will search only, it will match only the given case of that word. So global means it will search for all the instances. No mode means it will match, it will show the result of first match. Case insensitive, it will match without considering case. Single line mode or flag will mean treating the whole text as a single line, and multi-line mode means treating your test string consisting of multiple lines. So these are the basic regex modes. Thank you.
Hello.
In this lecture, you are going to learn about meta characters or special characters. Because we want to do more than simply search for literal pieces of text, we need to reserve certain characters for special use. Now, to understand the concept of meta characters, let's see this test string. Okay, the test string is, this is a cat, period. The color of this cat is white, period. John loves his cat, period. Do you have a cat? Question mark. John went to a village last year, parenthesis, 2017, parenthesis close, period. Now, if you want to search a literal character A in this test string, you will write A here, and you can see there is a match. Total there are about 11 match here, and it has matched either A as individual character letter, or it is within certain word like in cat and in have, etc. So this is literal match or literal character match. Now if you want to search the word cat, cat, so this regex has matched cat here, and there are 4 instances. So this is very simple. A means A and a cat means cat, and they match just normally like we have discussed in literal characters. Now if you want to match this question mark, or you want to match question mark in your text, you type question mark here, and instead of a match with this one, there is only one question mark in our test string. There is a pattern error. That means the match information is your pattern contains one or more errors. Please see the explanation section above. So it is an error. Similarly, if you want to match parenthesis, here is the parenthesis. Instead of a match with this opening parenthesis, again there is a pattern error. One thing is clear: matching a question mark or matching a parenthesis is quite different from matching A or matching a cat or matching a car. Question mark and opening parenthesis and closing parenthesis have special meaning in regex instead of their literal meaning. So we can say question mark and parentheses have special use in regex, and hence they are special characters or commonly called as meta characters. Okay, one more example. Let's suppose you want to match a dot, period in your test string, like here this is period, this is period, and you print a period here, and instead of matching this period, it has matched almost everything, every character, even spaces and periods. We were expecting that a period will match a period, but it has matched everything. This shows a period or dot has special meaning in regex instead of its literal meaning, and hence a period is also a special character or a meta character. So we define meta character as a meta character is a character which has special meaning instead of its literal meaning. And you are going to use meta characters in regular expressions to define the search criteria and any text manipulations. And most meta characters are errors, pattern errors, when they are used alone. Hello. In this lecture, you are going to see the 12 basic meta characters with special meanings, and you cannot use most of them alone, as it will cause a pattern error. / of course is a meta character because it encapsulates your regex. In addition to that, the first and important meta character is \. Second one is caret, then pipe symbol. Usually on keyboard it is on the same key of \. You can use it with shift, then a period or dot, a $sign, question mark, asterisk, plus sign, opening and closing parenthesis, opening square bracket and opening curly bracket. These are the 12 basic meta characters, and they have special meanings when used in regex. This group of meta characters is called single character meta character. There is another group of meta character which we are going to discuss in later lectures, in which we use \ in combination with a literal character, and which creates a regex token with a special meaning. You have to be careful while using these meta characters. These characters are reserved for special use, and we are going to study these meta characters and other meta characters throughout this course. Thank you. Hello. In this lecture, you are going to learn about how to escape meta characters. In the previous lecture, we discussed meta characters, the characters with special meanings, and they perform specific function in regular expressions. And using most of them alone causes pattern error, or they produce unexpected results. But what if you want to match these meta characters? If you want to match a question mark or a parenthesis or a period, because simply writing here like question mark, it will raise a pattern error. Or if you want to match a parenthesis, again a pattern error. Or if you want to match a / in this URL, again a pattern error. So what is the solution? The solution is we use a \ just before a meta character to escape it. Like here, this question mark is a pattern error, and we write a \ just before it, and here this is a match. When we use a \ just before a meta character, it makes a meta character just a literal character. Its special meaning vanishes, and now you can easily search and match any of meta characters just like any other literal characters. Similarly, a parenthesis, no match, instead a pattern error. We want to escape this, and we want to match an opening parenthesis with literal meaning. Now we use a \, and it has a match and the error is gone. Why? Because we have escaped this meta character, and this meta character opening parenthesis has become a literal character. Similarly, \ period, and it will match only the periods in your test string. And for escaping a /, this is / and a pattern error, using a \ before it will escape the meta character behavior, and now it will match the /. Hence, the rule of escaping a meta character is using \ just before that specific meta character. You can use this method with any of the 12 basic meta characters. Now one more example with searching for a specific URL. Now this is our URL and we want to search for it. By writing this specific URL here, https://www.mysite.com/folder/page.html. Exactly the same string written here in regex, and it has created a number of pattern errors, 1 2 3 4 and these dots. Now if you want to match this URL, we have to remove the errors. By examining our regex, we come to know that our regex has two types of meta characters: forward slash, forward slash, forward slash, forward slash. So 4 forward slashes, and period, period, and period, 3 periods, forward slash and period. We will have to escape these meta characters one by one using a backslash before each meta character. So this is forward slash, a backslash here, another backslash. These two forward slashes are escaped. This period backslash, this period backslash, this forward slash, a backslash, backslash, and backslash. And there is a full match. You can see here full match. This is a full match. Why? Because we have removed the errors. How? We have put backslashes before every meta character. Hence, if you want to escape a meta character, simply put a backslash before it. Thank you. Hello and welcome to Regular Expression Basics Part 2. In this lecture, we will discuss some more meta characters and their application. In the previous lecture, we discussed 12 basic meta characters with special meanings. But these meta characters are single character meta character. There is another group of meta characters which include a backslash at their start. In fact, two character combination is used as a meta character, and they lose their specific behavior when used alone. The backslash in combination with a literal character can create a regex token with some special meaning. So, some meta characters, the single character meta characters, are escaped by using backslash before them. However, some literal characters are made meta characters by using a backslash before them. The first example is backslash d. D is in lower case. Now this meta character backslash lowercase d will match any decimal digit from 0 to 9. Here, if we use d alone, it will be a literal character and it will match any occurrence of d in your test string. However, if you put a backslash before this d, it will change into a meta character and it will match any decimal digit from 0 to 9. So if you place a backslash before d, it becomes a meta character. Backslash d matches a digit from 0 to 9. So you can see in our test string, backslash d has matched all the digits here. Hence backslash d is a meta character. Backslash uppercase d matches any character other than a decimal digit. So it will match everything, leaving the decimal digits from 0 to 9. If I write here uppercase d, and you can see it has matched the spaces and alphabets and these symbols, plus, minus, parentheses, hash, etc., and just left the numbers. So you can see that backslash capital D or uppercase D is just opposite to backslash lowercase d, matching anything but numbers. The next meta character is backslash lowercase w. It matches any word character, uppercase from A to Z, lowercase from A to Z, and 0 to 9. The alphabets and numbers are called word characters, so it will match any word character, backslash lowercase w. If I write here backslash w, and you can see it has matched capital, uppercase A to Z, lowercase A to Z, and numbers, but it has left spaces and any other characters. So backslash lowercase w will match from A to Z, upper and lowercase, and numbers from 0 to 9. And the meta character backslash capital W, what will it match? Yes, it matches any non-word character, everything other than this, leaving this and matching every other thing. You can see here, if I write here uppercase W, and it has matched every other thing which was left in previous example, the spaces and the symbols, etc. It has left alphabets A to Z, upper and lower case, and 0 to 9, the numbers. Every other thing is match. Backslash lowercase s matches any white space character, and backslash capital S matches any non-white space character. Now I put a tab here, 1, 2, 3, 4. Now in this test string there are spaces, there is a tab, etc., and I am going to write backslash s, and backslash s has matched all the spaces and tabs in this text. Technically it matches any white space character. Space is also a character in regex. And what will be the behavior of backslash capital S? Yes, you are right, it will match everything but white space. If I write here like this one, and okay, leaving the space, white space and tabs, etc., and matching every other thing. So here are 6 more meta characters. When used alone, upper and lowercase d, upper and lowercase w, upper and lowercase s are literal characters. But if we use a backslash before them, then this combination only is a meta character, and backslash lowercase d matches decimal digit, backslash lowercase w matches any word character A to Z, upper or lowercase, and 0 to 9, and backslash lowercase s will match any space character. Backslash with uppercase of these letters will match the opposite of what it matched earlier. Thank you. Hello. In this lecture you are going to learn about non-printable characters and how to match them in your regular expressions. So we are going to see meta characters for non-printable characters. You can use special character sequences to put non-printable characters in your regular expression. 2 of these, the most important ones, are tab and new line. Tab is represented by backslash t and new line is represented by backslash n. The first question is, what is the use of such meta character? Let's see here. The test string is this is a car, and if I write here this is a car and there is no match, this is the same text string and also there is no error, but there is no match. So the printable characters are same. Where would be the difference? In non-printable characters. So non-printable characters are also important. Literal characters are exactly same. This is a car. Now we will look for non-word characters with our / uppercase W. And we come to know that this is a space, this is a space, and this is a tab. And a space will not match a tab. If I write here with space, THIS, this is a car. Now this is a space character and this is a tab character. It will not match it. In order to match this, what we have to do? We have to use /T. And now this is a match. This was the reason that it did not match earlier. Similarly, let's delete this tab from here and make it one space. Now this is a match. But if I move this car to new line here, again it is not a match. It is a match here. This is a space and car, and if I move it to new line, now there is no match. For new line match we have to use \n here. By using \n here, okay, not here, before car, okay, car, and this is \n. When we place \n, new line and car here, so it matches. This is a car and this is new line car, and after car we place a tab which I bought yesterday, and here if I write which I bought yesterday, and there is no match. Why? Because there is a tab before which. We have to place a tab here. So \T is tab, \n is new line, and \V is vertical tab, rather vertical space. Actually, some of the flavors treat it as a vertical tab and some of the flavors of Regex treat it as a vertical space. So it depends on the language in which you are working. \R is carriage return and \F is form feed. Now if I move it to down here, yesterday here, and now there is no match, and if I write before yesterday \V, and now again it is a full match. This is how you can use meta characters for non-printable characters in your test string. Thank you. Hello, in this lecture you are going to learn about the dot or period meta character. Dot or period matches all except new line. In regular expressions, the dot or period is one of the most commonly used meta characters. It is also called a wildcard as it will match any character. However, you have to keep in your mind that it is the most widely misused meta character also. So you have to use it with care. The dot matches a single character without caring what that character is. The only exception is line break. Now this is our test string. Here we have uppercase A to Z, lowercase from A to Z, the numbers 0 to 9, and all the special characters which you usually found on a keyboard. And now if I write dot meta character here, and you can see that dot has matched all. So dot matches all except new line. It is not matching new line here. Now what is the meaning of matching new line? Okay, let's see. The last character in first line is uppercase Z, then a new line, then another new line, and then there is A. So you can see after Z there is a continuous matching up to A. So here this line and new line characters are matched with \n 2 times new line. However, here with dot meta character you can see that the new line character is not matched. This is the exception. Now in this case we have our test string consisting of 5 words: car, tar, jar, par and far. All of these words are ending in AR, so this is the common AR. As dot matches all but new line, hence if I put a period here, and this is a match for all of these words. Why? Because AR is common in these words, and dot means any character. So here it is C, here it is T, here it is J, P, F, and any character means if there is space AR, it will be a match. If there is dot AR, it will be a match. If it is hash AR, it will be a match. If it is plus sign AR, it will be a match. So dot means any character. So this regex means any character AR. So dot will match not with alphabets but with symbols or with numbers also. Like 9 AR, it will be a match. Sometimes we have file names with numbering and we want to match all files with some common name, like file 1, file 2, file 3, file 4 and file 5. So how to match file of this type? Okay, file file dot, it will match all files with these specific numbers. But please keep in mind that dot matches one character. So if I change it to, let's say, 7, it is not a complete match here, because dot means one character. It could be any character other than a new line, but it must be one character. Hence file 57 is not a complete match or full match. Usually we have file names with extension like file.txt or file.html, etc. Now let's suppose you want to match files of .txt extension. Now what will be the regex? File.txt. So it is a full match here. Now is this a satisfactory or okay regex for extension? I would say no. Why? Okay, let's see here. File for txt, a match. File hash txt, a match. File space txt, a match. Now why these are all matches? Because dot means any character, and space is also treated as a character in regex. So 4 is any character, hash is a character, space is a character. Hence all of these are matches. Now if you would like to match only file.txt, then what you are going to do? Change this dot into a literal character, backslash period txt, and it will match only file.txt. So it is necessary in these cases that you change the behavior of period or dot from metacharacter to a literal character, so that it should match file.txt and it should not match file space txt, file hash txt, etc. Similarly, if you want to match numbers with decimals like 12.34, 12.34, it is matching this number. However, it will match these terms also: 12q34, 12934, 12 plus 34, 12 multiplied by 34, and 12 minus 34, and 12 divided by 34, etc. So here, if you want to match this 12.34, a decimal number with decimal point, simply change the behavior and change it from a meta character to a literal character, means simply a dot. Now it is matching 12.34. If you refresh your memory about modes in regular expression, then I discussed single line mode. I told you it is simply treating your string as a single line, and dot matches new line character. Now our test string is this is a car, and our regular expression is also this is a car. It is a complete match. But if I move it to a new line, this is a car, it is not a match. And if I place dot here, period, it is not a match, because dot does not match new line. But if I change the mode or flag from here to single line, dot matches new line, you can see here it is a complete match, full match. Now dot is matching new line. However, this feature is not supported in Ruby and JavaScript. If I change the modes from single line to, and I remove this flag of dot matches new line, and now it is not a match, and single line, and it is treating your whole test string as a single line. So dot is matching this, because now it is not treating this as multiple line, rather in this mode you treat your whole string as a single line. So this is about dot meta character and about its uses. Thank you.